All right. We're looking over the square root worksheet 1 here. And the things we didn't get to in class, I will go over together with you guys. So you got up through number 9 in class. So if we're taking a look at number 10, I look at that square root, I'm thinking, what are my perfect square factors of 24? I think, my perfect square factors of 24 are 6 and 4. So I'll rewrite that as 2 times the square root of 6 times 4 inside the square root. And then I think the next step, when I'm removing that 4 from the square root, I'm taking the square root of 4, so that becomes 2 times this 2 that I'm writing right now is what that square root of 4 was, and I leave the square root of 6 inside, and I'm left with 4 times the square root of 6, I think. Lastly, are there any factors of 6 that are perfect squares? No, I'm all done. I can circle my answer. All right, number 12. Here I'm thinking any perfect square factors of 25, and I realize that 25 is a perfect square. So I'm taking the square root of a perfect square, so I just get the number, whatever that is. So 3 times 5, which is 25, the square root of 25. And that is the same thing as 15. So I got a nice whole number answer for that one. Then I'll take a look at 14 next. Looks like we had 11 square root of 3 plus 11 square root of 5 minus 4 square root of 3. My like terms are 11 square root of 3 and 4 square root of 3, just like 11x and 4x, right? And then that we can think of that square root of 5 as a y. 11 minus 4 gives us 7 square root of 3. And then I tack that 11 square root of 5 on the end. I think, do I have all my square roots simplified? Yes, I do. All done. 15. I've got a bunch of 1 times the square root of 6, right? Or just square root of 6. So how many of those do I have? I have 4 times the square root of 6. I think, is the square root of 6 simplified? It is. I'm done. All I'm doing is adding those coefficients when I'm adding something times a square root. And all the square roots are the same. 16. When I'm multiplying, as we're going to notice difference multiplying, I multiply the coefficients first, so I get 24. Then I multiply what's inside the square roots, or what's the square roots are. And that's square root of 5 times square root of 5, which gives me square root of 25. I think I already know what square root of 25 is. That's 5. So I have 24 times 5. That would give me 120, I believe. 120. Nice round number for that one as well. Number 18, I'm multiplying again. I just got a lot more here. So this time I'm going to pair up my square roots here. I know that these two are just going to give me whatever's inside, right? So I'm going to, those 2 square root of 6s are just going to become a 6. Those 2 square roots of 7s are going to become just a 7. And then I have a 2, a 6, and a 3 in front of that. So I just need to multiply all those parts out. So I got, 12 times 3 is 36, times 6 is 216? 216, I think is right. Point is, I need to multiply these out, and I'll get a nice whole number answer here again as well. Don't have my calculator on me. Let's see, number 19. This one we talked about how the square roots of 3s are like variables, so we can kind of cross those out. And then we get 6 times 12 over 2. These cancel as well. Again, we're multiplying, so that becomes a 2. Or no, that becomes a 6, sorry. 6 times the square root. And then I said we can rewrite this double square root as just a big square root of 15 over 3. So now I have 36 times square root of 5. And I'm done. That's one of our properties we use there. And then 8 over square root of 2, this is a question where we must rationalize the denominator. So I'm going to multiply it by square root of 2 on the top and bottom. Again, that's just like multiplying by 1. It's just a special one. We call it a clever one. 8 times square root of 2 over square root of 2 times square root of 2 is 2. I can cancel those 8s and 2s, and I get 4 square root of 2. I'm done. See how many we've got left. 21, 24, and 25. 21, square root of 6 times square root of 6, we already said. That's just 6. It's one of our properties, something we've seen before. What about square root of 16 times square root of 8? We are going to have to multiply this out. That's going to give us 80 plus 48 is 128. And that's inside the square root. Now I think, what are my factors of 128 that are perfect squares? So I'm thinking 128 factors of perfect squares. I got 4, I got 9, don't think 9 is going to help us much. Let's see, 90, 108. That's not going to help us much, but 4 might, right? 120. 4 times 30 is 120. So that would be 32 times 4. So I think I'm a little short there. We can try it that way. We can write this as 4 times the square root, 4 times 32 within the square root, right? And we can pull that 4 out. That becomes 2 times the square root of 32. Obviously, 32 has some nice even factors at 16 times 2, so you can write that as 2 times square root of 16 times 2. If that 16 comes out, I get 2 times 4 times the square root of 2, and that's 8 square roots of 2. I'm done. Okay, so you could have found that 16 at the beginning. That might be quicker, but again, whatever method works best for you. Lastly, here we have 18 over 2, and square root of 6 is cancel as well. That just becomes 9, and I'm done. Okay, those are your solutions for these. Let me know if you have any questions. Reach out with an email or Canvas message.